Hey folks, Knox with IT Inspired here. We are ready to wrap up our SQL journey and talking about maybe the most important topic there is, and that is going to be backups. Man, I hate to say it, but disaster strikes. It's not a matter of if, it's a matter of when. And it's so important that you've got a good backup strategy in place to go about restoring your databases in your time of need. So let's talk about what the best way to accomplish that is. There are options available to you based on your database needs and based on your RTO and RPO. What are those acronyms anyways? Well, that's recovery time objective and recovery point objective. How long can you be down and how much data can you afford to lose? Some items are super quick and easy to restore, while others you need the flexibility to be able to restore down to any second so that you can minimize the amount of data loss. For instance, let's say you get attacked and hacked at 12:31 p.m. and it would be great if you could restore to 12:30 and 30 seconds. We can do that in SQL Server if we configure it right. But let's get started with the most fundamental thing, and that's where to store our backups. I know we already talked about this quite a bit, and I am going to bring up the Hyper-V console real quick and we can take a look at this a little bit closer. We're working in SQL Dev Test, which is where we have the SQL Server Developer Edition installed so that we can do a little more high functioning things like using the SQL Server agent. So in this case, you can see I have a disk called SQL Data, and that's where I store my SQL data, and a separate disk here called Backups. Now, if this was a bare metal server, as in Windows operating system installed directly onto physical server hardware, these would represent two completely separate hard drives, right? Maybe they're actually different RAID levels underneath these hard drives, and that would be perfectly acceptable to store your backups on a different set of disk subsets, or a different subset of disks, excuse me, than the SQL production database itself. But as you just saw, as I just blatantly showed you, this is a SQL Server VM. And where I've got these stored, I've got the SQL back. You can see it's stored into this cluster storage volume 1 SQL Dev Test. They're actually stored on the same exact folder as the production data. This is the number one thing to not do, okay? If you take one thing out of these 9 SQL videos away from me, take this tidbit away. Store your backups on completely separate disks than your production data. And if you absolutely insist on storing your backups on the same disks, even if they're in a different folder, then if you insist on storing the backups on the same disks as your production data, then you better have a backup plan in place that backs up those SQL backups, as in server level backups or any sort of server level storage replication where changes that take place are replicated to a different set of disks. There is a backup strategy called the 3-2-1 rule. I encourage you all to research it on your own time. But yes, at a minimum, what I am insisting you do, if you're not shipping backups somewhere else, if you don't have cloud-based replication or cloud-based backups, then please don't do what I do here in this virtual machine and store your backups on the same set of physical disks as your production data. So keep that in mind. This is just a lab environment, and I'm just trying to illustrate in a scenario where the data may be stored on a different place as your backups. That is what you want. Okay, now that we've covered that, let's talk about the actual backups themselves. Remember when we were creating this database, we talked about something called the recovery level. So we had a few options, and the two most popular options that you will more than likely run into in the wild are simple and full. So let's start talking about simple first, because guess what? It's the simplest. Well, what simple does is it doesn't record every single bit of information that possibly happens on this SQL server. That is what the log file does. The log file is all about storing important events that happen on this SQL server so that in the event of a restore, we can restore to that point. Well, what the simple does is it doesn't really record that much in your log file, and therefore the log file doesn't really grow. It pretty much stays static, and when you're set to simple, you could take a full database backup where it copies down every single bit of info about this database, and the soonest you could restore to in the event of a database failure, if you were to go here and then hit restore and then database, the best that you could restore to is essentially whatever database backups you have in place. The transaction log will not be consulted to figure out what happened exactly at what time. It's just going to go to that backup and restore whatever you've got in those full backups. So the summarization of the simple recovery model is it's not going to record a whole lot of information for you in the transaction log, and thus if you have to restore, there's a good chance that you're going to lose data involved. For instance, if you take full backups once a day, and that's the only backups you take, then there's a potential that you could lose 23 hours worth of data. If in the 23rd hour you get hacked or have a database corruption or a disk failure and you have to restore, you would be rolling all the way back 23 hours. So keep that in mind when you're picking these out. If you don't have a super intensive database, if you're not if losing 23 hours worth of data doesn't actually represent that big of a risk administratively, it may be easier for you to just go with the simple recovery model and just take daily backups or something like that, where you won't have to deal with those pesky transaction logs growing out of control. But as you saw here, when we set up this database, I chose to do the full recovery model. And like I was saying, that basically means that this transaction log, let's go take a look here in this log. See, it's like exactly the same size as the database itself, right? That's because every single thing that goes on this database is happening in the log. And what we have to do to stop this log from growing out of control is we have to run database backups. Database backups truncate or empty the log. Now that doesn't mean this file size goes down to 0. It just means that all of the data that was contained within this file is essentially zeroed out, and it will then start at 0 and grow up to this file size. And once it reaches this file size and it needs to grow even more, it will. It'll just keep growing. In fact, it's not uncommon to go into, I can't tell you how many times this has happened to me. I've gone into a production environment, hey, the SQL server's not working anymore, what's going on? Well, they had the full recovery model, never ran backups, and the log, let's say they had a 4 gig database, they had a 250 gig log file. That's what I'm talking about. If you don't do this right, if you don't set up your backups right, it is inevitable that you will run out of disk space because this pesky log file. So let's talk about this. Let's talk about the best way to do these backups. So we had to do this in the developer edition so that we could actually get to these maintenance plans. And these maintenance plans do just what they say. They maintain your SQL Server environment, including running SQL backups. So what I want to have happen is I want to have a full database backup run once a week on MyPartyDB, a differential database backup, which means any changes that have happened since the full database backup, just the changes, will be stored in that. I want to have that run 2 or 3 times a week. And then I want to have my transaction log backups to truncate that log file run maybe once every 3 hours or something super frequent. Let's get started doing it. Let's do maintenance plan wizard. How about that? That's going to make it a little bit cleaner. And we're going to call this my party DB backups. SQL Server agent account is fine if you are backing up to a remote share, maybe a shared folder. You want to definitely make sure that you set up this agent service account to be a domain service account that would have access to that share. All right. we're going to have 3 separate tasks here for the full backup, the differential backup, and the transaction log backup. So I'm going to say I want separate schedules for each task. What tasks do we want to do? Well, guess what we just talked about? Full backup, differential backup, transaction log backup. Great. So we're going to have the schedule for once a week for full, 3 times a week for differential, and frequently throughout the day for transaction log. Yep. Are you sure you want to do this? I definitely am sure I want to do this. Great. So the first thing we got to do, we're on the full task here, you can see. We got to pick which database we want to back up. I'm going to pick MyPartyDB. That's the guy we're concerned about. We are backing up the database itself, and down here is the schedule. This is where we're going to set this to recurring. Obviously, I want this to happen, and I want it to happen weekly on, how about Sunday at midnight? That sounds perfect. I'm not going to change anything here, so we're just going to do recurring, weekly, on Sunday at midnight. Okay. Next. Now we're doing the differential backup. I am going to pick on MyPartyDB again, and I'm going to go to change. And now I'm going to have this run on Tuesday, Thursday, Saturday at midnight. Perfect. So it's going to run 3 times a week. And then we're going to go to... We need to do a little bit more work here. Let's go back. Sorry. All right, so we've got the destination. This is cool. Let's create a subdirectory for each database. So we're going to go to the destination tab, and we're just going to make sure this is okay. The file extension. SQL Server saves full and differential backups as the BAK file. The transaction log backups are TRN. So now that we're comfortable with this, that it's going to run, it's going to create a subdirectory in this folder for the database backup, and it's using the BAK extension. I feel good. Let's move on back to that differential. Make sure it says the same thing. Yep, we're going to check this box for the subdirectory. Differentials again, use the BAK. We're on the schedule. We're good to go here. All right, now we're doing the transaction log. Guess what? Notice that we've noticed these databases keep dropping off, right? There's not a whole lot here. Well, guess what? It's not going to show you the databases that are either offline or don't use the full recovery model. So in this case, we're really only looking at 2. I'm just going to go with MyPartyDB because that is full recovery model. And we're going to schedule this to daily. And let's see, occurs every, how about 3 hours, starting at 1 a.m. That works for me. So we've got daily, occurs every 3 hours at 1 a.m. If you have a high volume database, if you have an actual application, maybe a web-based application where you have a ton of users accessing it, you're going to want to really amp this up. 3 hours is not going to cut it. It is actually recommended for production databases where there's even a decent amount of volume to do every 15 minutes. Whoa, right? Yep, that's what you're going to want to do just to prevent that transaction log from growing out of control and so that you've got super flexible restore points. Let's hit OK here and make sure our destinations, and look, it set it to that TRN file. That's what we want. We're going to make sure we've got the create a subdirectory. That's great. Okay. We can write a report if we had configured database mail, which is 2 levels down beneath this maintenance plan. You could actually have it email the report. That's outside of the scope that we're trying to cover here in this video, so we're just going to leave this as fine. And here's your maintenance plan. It looks like it's ready to roll, and hit finish. And just like that, the maintenance plan is complete. In fact, if you actually expand the jobs here, look at that. The agent now has your jobs scheduled and ready to roll. The backups will take place. I highly recommend at this point taking a full backup to kick off your database backup process. Yep. This looks good. This copy-only backup, this is super important. So when these backups take place, SQL logs the chain of backups that go on. So remember we talked about the full backup and then the differential backup, which backs up everything since the last full backup, and then transaction logs, which back up every single transaction, right? If I were to just come along, let's say I've got backups running, I took a full backup on Sunday, it's now Wednesday. If I were to take a full backup right now, guess what? That means that if I took that full backup and I moved it off the disk, let's say I backed it up to a USB drive and then took that USB drive home, guess what? If I needed to restore at any point, I just broke that backup chain, because the transaction log backups that came after that were just, and the differential backups, they were counting on having that full backup that I just did, that I backed up to a USB drive and left with. So to prevent those types of issues from coming along, like a very overzealous developer who wants to copy a database, take it home to work on it, you would use a copy-only backup. Those backups are not logged in the SQL chain of backups. So if you need to just copy a backup for someone else to work on, you don't want them to alter your production database, but you want them to see it, you would use a copy-only backup. Super important to remember that before you just take a backup of something and then take it home and work on it. Which, by the way, that's how a very large and important United States credit bureau got hacked recently, as a developer took a backup and took it home to work on it. Anyways, I am not going to do copy-only backup because I want the chain to see that there is a full backup in place. It's going to back up to the backups, and I just hit OK. And look at how quickly that completes, because it's such a tiny backup, or such a tiny database. The larger the database, obviously the longer it will take to back up. And we hit OK. At this point, the backups are set to run. Now, we talked about that disk space usage. That's pretty important, right? Especially if we don't want the transaction log to go out of control. But we didn't set up anything to clean up our backups. The backups could just run for forever, right? Well, there's a maintenance plan for that too. That's the maintenance plan, the cleanup wizard. We'll go right back through this. We're going to call this backup cleanup. We're only going to have one task here, so we're going to click next. In fact, you know what? I'm going to schedule it to run on Sunday right after the full database backup is taken. So how about 2 a.m. on Sunday? Okay, and let's do not cleanup history, maintenance cleanup task. That's what we want. All right, next. So we're going to search. We're going to delete files of the following type: backup files. Right? Search folder to delete files based on an extension. We are not going to delete the data files. We're going to delete backup files. So we're going to go to the backups. And we're going to do include first level subfolders, because remember we told it to delete things, or excuse me, we told it when it was backing up to make a subfolder for each of the databases. Now the extension, it's not just .* like you would think. You actually have to specify the file name too. So *.* means it will delete anything in that folder right here. How old? If it's older than 4 weeks. So again, depending on your database sizes and your RTO and your RPO and how much disk space you have, you're going to have to make all these decisions on your own as to how often you want to back up your databases and how many databases you want to keep on hand. But you're going to hit this right here and that and finish. And just like that, we now have a cleanup plan in place to delete the backups that are older than 4 weeks old. That is database backups, guys. This is so important. Get out there and try it out. I hope you've enjoyed the SQL series as much as I've enjoyed making it.